Good afternoon, everyone. I am Biplab from IIT Guwahati. I am the instructor of this course, Data Analysis for Biologists. This is our second live session. A few weeks back, I met many of you who joined the live session. Apart from me, we have one TA, PMRF TA. She is regularly conducting live session every week, discussing different problems, going through each chapter, each section in details, showing about different numerical problems, solving them in front of you. I hope you have joined that live session. Let us first put forward the agenda of today's live session. In today's live session, what I will do, I will go through week 5, week 6, week 7's key point. In the first live session, which is still available on YouTube. If you have missed that, you can go back and check. I have discussed about the key point that one person should pay attention to for week 1, week 2, week 3, and week 4. So these 4 chapters were discussed in the first live session, right? Live session 1. What I will discuss today, week 5, week 7, 6, and week 7. Week 8, we have not reached yet. A brief idea what will come in week 8. Fine. So I will discuss about the key points that one should pay attention more while watching the videos and other things. Next thing what I will discuss how you should prepare for the final examination. Many of you have registered for the final examination. So I want to discuss in brief how you should prepare for that, right? And in general, also I will discuss about different logistical issues that may occur in this course. And we will also discuss the third thing that we will discuss about the queries that you may have. So there are 2 ways you can put forward your queries during the live session. If you have joined us through the Teams meeting, then you can use the meeting chat. If you have joined the thing from the YouTube live, then you can also post your chat there. In between, I will check those chat windows and then I will answer your queries. Some of you have already used the online form that has been circulated to put forward your query. I will answer that. So let us start. Before I start and go into each chapter's discussion from week 5 to week 7, let me remind you that this is my second and the last live session. So this course will be ending in 1 week, and then very soon you will have the final examination. So we'll wrap up. There is no more time for me to meet you on the live session. But as I have said, our PMRF TA every week, she is organizing a live problem solving session. I insist, please join that. This week also there is a live session. All these informations are provided in the announcement. You must be getting the email also. If you go to the announcement section, you will get the Teams link for joining the course, right? Also, these all live session, if you have missed some of those, these are also available on YouTube. Those links are also provided in the course portal and the announcement section. Please go through them thoroughly. I can assure you these live sessions by the TA are extremely useful if you are preparing for the assignments and the final examination. And she meticulously go through each aspect of the topic taught in every week. So it will be very helpful for you. Now, let me go to week 5's main questions that you should pay focus on. Also, before that, let me, I'll come back to this exam issue. Let me go to the week 5. So in week 5, we are primarily dealing with regression model, right? So regression models are where you have a data set and you believe that suppose 2 variables, X and Y, or suppose blood pressure and age, blood pressure and smoking habit, these type of 2 variables, or more than 2 variables, they have some sort of association, some sort of relationship. and you want to represent them by mathematical model. The simplest one is linear model, y equal to mx plus c. So x is one variable, y is one variable. You believe these two variables are connected with each other using this simple linear relationship. You do not know the value of m. You do not know the value of c. You want to estimate this from this data, right? As you are estimating this m and c, unknown parameter of your model, these are essentially called machine learning. So all the machine learning is a mouthful of word and everybody now talk about it. The simplest machine learning you can think of is actually linear regression. So in this week 5, you have gone through linear regression. So what you should focus on linear regression. Before I tell that, you must have noticed that in the first lecture of week 5, we have discussed about correlations. So please pay attention to those lecture. You have to learn the basic concept of correlation. Why we require correlation? Actually, before building a model, whether linear, non-linear, doesn't matter. You are supposed to create go through the data, if possible, visualize it, and then try to check whether there is any association between different variables or not. And that's where the utility of correlation coefficients comes. So you must be aware of why you are using correlations. And the common correlation coefficient that we use is usually the Pearson one. And then in some cases where we know the relationship is not linear but non-linear, but it is still monotonic, then we use Spearman and Kendall correlation. These are very easy to calculate. Don't just look into the formula and try to mark it up. Try to understand each of the formula for each of these coefficients, Pearson correlation coefficient, Spearman correlation coefficient, Kendall coefficient, and also practice by paper and pen for a small data set, say suppose sample size 4, means 4x values, 4y values, and you try to calculate these your computer, you don't calculate yourself, you will never learn. So try to do it by paper and pen, right? Then only you will make mistake and you will learn. Fine. And also particularly if you are preparing for exam, these are very common, not just in this exam of this course, in other exams and interviews, these are very common because anybody can calculate by paper and pen these parameters, right? These correlations. Next, there are 2 lectures on linear regression. Simple linear regression, right? And linear regression, I have covered briefly. There are 2 methods. One is a classical method which actually uses calculus. We have not done the derivation, but we have shown that how to calculate m, the slope. My equation is y equal to mx plus c. I want to calculate m and c, and we have shown that m, you can easily calculate that m will be nothing but covariance between x and y, and the divided by variance of x. Whereas how can you get the c? You can get the relationship of c from this relation, that y bar, mean of y, equal to mx bar plus c. So c is unknown. If m you have already calculated, you can easily calculate c. This one also, don't leave it to R, because we had a session where we have taught you how to use R using its LM function to do linear regression. Yes, in reality, when you will be in research or working for a company where you have to do linear regression, you will repeatedly use that LM function to do the regression, right? You will not do it paper and by paper and pen. But for this course, as you are learning, I insist, take a data, create a synthetic data, just create a data and do these calculation, calculate M, calculate C manually by yourself. Then you will learn what it is doing. Then you will not do mistake in future, even if you use the tool, the ready-made software, right? So I will insist that please look into that. Now, apart from that method, we also taught you the matrix-based formulation. Remember, when you use the LM function for linear regression, polynomial regression also in the next week, in the 6th week, we have taught using the same LM function. that actually does not use this formulation of covariance of x by variance of x to calculate m. It actually uses linear algebra based approach, and that approach is very powerful, right? So now the thing is that how do I convert my linear regression or nonlinear regression problem into a matrix format so that linear algebra could be used? That is the tricky one, right? Again, I will remind you, when you will do this in reality, you will be using R. You don't need to convert your data into matrix format. R will do it for you. You will take a data frame and then you will simply use the LM function, and you have done that. When I have shown the video in the lectures where I have shown how to use the LM function in R to do those things, and you must have learned it. But again, I will insist, please try to do it yourself, right? So if you have a data set where you have X values and Y values, right? And then you want, suppose X1 corresponding to Y1, then up to Xn, up to Yn. How do I convert it into linear regressions format for linear algebra response? It will be something like this. I will create a Y vector where I will have this. And then I'll create a vector where my matrix where I'll have x1 up to xn here, and then one column of 1, right? This is tricky. This part most of the student misses, right? And then we multiply with a vector, which is actually A and B, the two coefficients, M or C, whatever you want to say. So this will be called Y vector, this will be called X. By simply using the linear algebra formulation, X transpose X, inverse of that into X transpose Y. This is a generalized format. Try to understand it, try to use it, this is a very common question again in exams, quizzes, interviews, that okay, I have a data set. How to convert into a linear algebra format so that it can be used for regression. That means they're asking you to either formulate this Y vector or they're asking you to create this X matrix. And most students will do a mistake. They will miss to put this one column with one values in that X matrix, right? Okay. So now this is what you should focus on. Then once we have done the linear regression, then we have to check the quality of my regression model, right? Whether these calculations for M and C, the value of M and C that I have estimated are really reliable or not. To do that, we have two things. One is you first calculate the R square, right? And this R square is nothing but, you have to remember this formula. This is nothing but Y1 minus RSS by TSS. This is again very common question in interviews and exams. What is the definition of R square? This is called coefficient of determination. This is not correlation coefficient. Again, a very tricky question asked in interview. They will ask, is it the correlation coefficient, Pearson correlation coefficient? No, this is coefficient of determination, right? It has a relationship with the Pearson correlation coefficient, but R square, capital R square is not the Pearson correlation. It is the coefficient of determination, although the symbol is a bit confusing. And then you should be able to calculate what is the meaning of RSS, what is the meaning of TSS, what is the relationship between RSS, TSS. If you remember, in the lecture we have taught, the relation is TSS equal to RSS plus ESS. Again, very common question. Numerical problem may can come, interview question may can come, and when you are working, you have to anyway calculate R square. So although again, R will calculate it for you, right? Or if you are using MATLAB or Python, this language, there will be function to calculate R square, but you have to understand what the meaning of. What can be the maximum value of R square? What is the minimum value of R square? What is the meaning that if R square is close to 1, these things, the physical meaning of this you have to understand. Then one point, possibly in the lecture also I have told, most people, most researchers, they will create a linear regression model and then calculate the R square and then they will stop. Suppose they have created a model whose R square value is 0.9. Very high, good. And they're happy. They stop their work there. That's wrong. You are not supposed to stop. You are further supposed to poke and check the credibility of value of M and C, slope and intercept that you have calculated by regression. And to do that, you have to use t-test. That also we have discussed in the class. And in the R session for this week, that week, we have also shown how to calculate get the statistics, t statistics, and the probabilities for these parameters, the coefficient, the slope, and the intercept. You should know what is the null hypothesis of this and how to confirm whether your estimated slope and estimated intercept are statistically significant or not. And sometimes you may also require to calculate the confidence interval. So remember one important point. Beyond this course, beyond exams and quizzes, linear regression, linear model are the most common model that we all use across all disciplines of science and technology. Wherever you are, suppose you are working for Amazon, you have some data or consumer behavior, right? And you want to create a model to understand how consumers are consuming certain types of consumer goods. The first thing you are supposed to do is to create a linear model, because the idea is if my model, a simple model can explain the behavior, I will not go for a complex. So everybody will create most of the time a linear model, unless you know beforehand from theory, suppose from physics or chemistry or economic theory, you know that two things are not linearly connected. They have non-linear relationship. Then obviously I don't waste my time calculating doing a linear regression. Otherwise, everybody in every field will first try to do linear model construction through linear regression. So I will expect that at least out of this course, you will learn this by heart. At least this one, you should not make mistake in your life. Right? Okay. I will stop right now. And if anybody has any query, so if anybody has any query, you can post it on the chat for the live or in the okay, it seems there is no chat, no query right now. So we'll proceed. You can also ask in the team if you have any query. Okay, so in week 5, we first go for correlations, different types of correlation. Then we go for linear regression, and eventually we go for multiple linear regression. Now, multiple linear regression, to achieve that, right? You have multiple variables. It is nothing but having more than one variable predicted. So in linear regression, there is only one predicted X. In this case, you have multiple. So Y depends upon A1, X1. X1 is one predictor. Then we write A2, X2. This is another predictor, something like that. And eventually a coefficient, a constant B. So I have to calculate this A1, A2, A3, and B. And to do that, again, we simply use that linear algebra-based approach of linear regression. So in this case also, from the data, I have to create matrices. Again, R will do it for you, but you should know because these are the common problems that we are asked in the exams and quizzes. So for this case also, I will create the Y vector, something like this, Y1 up to Yn. So n data for Y, and then it should be equal to X matrix. Now X matrix now will have more than 2 columns. So it will be x11 up to x1n. So the first column is for the first variable x1. Then the second column is x12 dot dot x1. Sorry, it will be xn1, xn2, something like that. So this is for the second variable predictor, independent variable. And then if you have other, you put them there. Eventually at the end, you add a column of 1. This is again, I remind you, this is where many students do mistake, that they miss this column of 1. And this should be equal to, and this should be multiplied with a b vector, which has a1, a2, dot, dot, up to b. So this is a very common thing. You should know how to create these type of matrices. And then eventually it will be solved to get the b vector to calculate this a1, a2, and all this thing. Again, if you have noticed in the lecture, we'll use the linear algebra based approach. We'll take the x transpose x, inverse that, multiply by x transpose, and multiply by the y. That's all. And that is why, as the linear algebra based approach is same for simple linear regression and multiple linear regression, this is called multiple linear because you have multiple predictor. Multiple linear regression are same. That's why the same LM function of R can be used, right? Now, again, once you have created the model, you have to go and evaluate the quantity. If you remember, in case of linear regression, we are using R square, the coefficient of determination. We can use it, but in the lecture, go back and check if you have not checked properly, is that there is an issue. Actually, R square misleads us. So we have to use the adjusted R square. Again, very common question in exams and quizzes and interviews. What is adjusted R square? What is the definition of? Why you want to use it over standard R square? What is the problem if I use R square for multiple linear regression, right? And then from the definition, somebody may ask you to calculate the value of adjusted R square. So these things are very handy things. You should learn them by heart and you should be able to answer those questions. And then again, you do t-test for each of the coefficient A1, A2, A3 up to B, and then whether they're statistically significant or not. But before that, actually, we have to do ANOVA or F-test. We have discussed the theory of that. We have discussed what is the null hypothesis of this. And in case of the R session, we do and show that how to do this ANOVA, right? One unique problem of multiple linear regression is the multiple collinearity problem. Multiple collinearity problem arises when you have some predictor which is linearly dependent upon another predictor. That means in my X matrix, this X matrix, I will have some column which is linearly dependent upon another column, right? This can happen many times if you do not design the experiment properly. And in the lecture, we have explained when it can arise and what will be the effect of this multicollinearity. What will be the problem if there is a linear dependency between different predictors? And it is not always easy to detect it, unless until you are very cautious about it from the very beginning. There are certain methods to estimate that. We have discussed only one, VIF, variance inflation factor, VIF. It is very easy to calculate. Anybody can do it by paper and pen also. So please practice how to calculate VIF because you can expect VIF-based problems in many exams, quizzes, and interviews. Right? That's all for week 5. So now in week 6, let me move to week 6. Week 6 starts with nonlinear regression, right? Now, nonlinear regression means something like this. Suppose the dependent variable y has a relation with a predictor, like suppose a x cubed divided by 1 plus x. So it's a nonlinear. How can I fit my data to this type of equations? Right? That is the question. So there can be many type of nonlinear regression problem. One is called polynomial regression, which can be solved using the standard least square approach. And we have discussed that in detail. So please learn that again very carefully, because it is nothing but extension of simple linear regression. Again, the same LM function, that's why it is used. And just like any other linear regression, you have to calculate, do the t-test for the parameters in this coefficient. For example, if I am doing a linear polynomial regression, like y equal to ax plus a1, a2x squared plus a3x cubed plus b. So these are my parameters that I am, a coefficient that I am estimating by linear regression, right? And I have to calculate whether these are statistically significant or not. And for that, we have to do t-test. One interesting thing, and very common in interviews actually, when we test whether somebody actually understand the building these nonlinear models, polynomial models, is that ANOVA. ANOVA can be used to detect whether I will increase these polynomial terms in my model. Should I make a more complicated model, or a simple model can work, right? So this is one common trick, and you should also learn that. And we have shown that in the R session of this, right? Because we have an R session on this polynomial regression, and there also we have discussed it. For some other problem, we can actually linearize the nonlinear one. And in the lecture, I have given example of this nonlinear to linearization. If you have nonlinear function, how can you linearize it? Unfortunately, you cannot do it for every nonlinear function, but many common nonlinear functions which are used in biological data can be easily converted into linear equation by simple trick. So those has been discussed in the lecture. Please pay attention to those, right? And finally, I just touch upon nonlinear regression, least square. I have not got deeper into the algorithms because that goes beyond the scope of this course. It will require much more mathematical rigor, but we have shown how to use the nonlinear least square function available with R. So please learn how to use it. Then we move into the concept of clustering and classification. So we have a dedicated lecture which teaches you the basic idea of clustering and classification. Hand in glove with these two things comes the idea of supervised learning and unsupervised. See, when you are doing regression, you have data. And in that data, you are putting an equation and you are fitting. You are learning. There are problems, some other problem also, where the machine in the algorithm will create a model, which not be equation-based model, some other model, right? For example, cluster. If you have some data and you believe these data can be broken down in clusters, you are actually creating a model. And what is the best cluster? Okay, you have an algorithm that is trying to infer what is the best clusters, right? So that is how it is learning. The machine is learning. So it's a machine learning problem. Again, in some cases, you may have to classify the data, right? You have got some tumor samples. You have done the gene expression study for that, and you have to classify whether the sample belongs to a cancerous tumor or a benign tumor. So it's a classification. Now, classification problems require labeled data. That means to create the model, to create the classifier, I require labeled data. What do I mean by labeled data? Means in the data, a particular data set, which I will use for building the classifier, we'll call them training data, right? It should be called training data, right? It should be used to create the model or a classifier. In this data, we already know, for example, the tumor case, I already know which tumor belong to which class, whether it's the benign one or a metastatic one. I know beforehand. Somebody has told me that, right? So that is the label data. You use this label data to create the classifier, and then a unlabeled data is used, right? So when a new unlabeled data comes, I can use that classifier to infer the classes, infer the class of that particular unlabeled. So classifiers are essentially example of supervised learning. Now, if you must have gone through the clustering thing already, right? So you must be aware that for clustering, I do not need any such label data. I do not know beforehand which data belongs to which cluster. So this is unsupervised. There can be some time where there can be a mixture of supervision as well as unsupervised thing. For example, we may go for some sort of clustering where beforehand we tell the algorithm, say that, see, these two things, these four things or these five things data point should belong to a single cluster, because I know beforehand that for some other property, they belong to the same cluster. So then the algorithm can take those as cues, clues, and do the clustering better. So that will be called semi-supervised clustering, right? That will be called semi-supervised. Right? And then after this discussion, we go into logistic regression. Logistic regression is one of the most common regression method, classification method is used for biology, ecology, in any other field you think of. Logistic regression is very common for classification. It uses sigmoid function, right, which has a form of 1 by 1 plus e to the power minus a plus b x, right, where x is the predictor. So please carefully understand why we use sigmoid function, right? And associated with that sigmoid function is something called the odd ratio or odd, right? So what is the definition of odd? We have discussed in the lecture. Check that, right? So you should be able to calculate the odd, you should be able to calculate the probabilities, and you should be able to connect these probabilities with odd, and then you should know what is the utility of that sigmoid function to calculate the probability. And if you remember, I have said in the lecture also and the example also that actually logistic regression is for binary classification. Either your tumor sample belongs to a benign tumor group class, or it is a metastatic one, a cancerous one. You cannot classify in between, right? But in real life, if you understand clinical data, we may have different other divisions, right? A metastatic cancer tumor can be classified as grade 1, grade 2, grade 4, something like that. So that means it is no more binary. What to do in that case? One option for that, and we have discussed in the lecture, and you should carefully learn that, is called one versus all algorithm, and it is used very regularly. Now, once you have learned them, please go through the R lecture where we have taught how to use the GLM function, generalized linear model function, to perform your logistic regression. As I have said, particularly if you are coming from a clinical biology side, these classifiers are very commonly used nowadays based upon the gene expression data. You want to classify patients, right? And logistic regressions are widely used. So you should be able to use GLM. You should be able to calculate the confusion matrix. And from there, you should be able to calculate specificity and sensitivity. Without calculating specificity and sensitivity, there is no meaning of creating this classifier. And again, I'll remind you, very common question in the interviews and then exams are, what is specificity? What is sensitivity? What do you mean by true positive rate, true negative rate, right? So you should learn them. The last lecture, if I remember correctly, in week 6 is based on different distance measures like Euclidean distance, right? Manhattan distance, Then you have Molanovis distance, chord distance. These are the distance measure which are used for different clustering algorithm. Right? Many other algorithm also required. But in this course, we have used those in case of clustering algorithm. So these equations for these algebraic equations for these different distances are very easy. So you should be able to calculate those distances by paper and pen. So please practice. So that is all in week 6. Is there any question up to this week 6? Okay, if there is no more question, let me go into week 7. Week 7, I have observed many times students find it a bit difficult to learn. But in this week, we are learning two very important clustering algorithms, K-means algorithm and hierarchical clustering. These are at the heart of any clustering work that you may have to do in your research or in your work. We have not got into the details of the algorithm. These are heuristic type thing. You do not have complicated math in it. You have to understand the logic step by step. So I have tried to explain it using graphically. Please step by step go through the video, and I believe you will be able to understand what is going under the hood for K-means clustering and hierarchical clustering. Eventually, you have functions to do this, both these clustering in R. So I have shown that also. There are 2 lectures on that, how to use K-means clustering using R and hierarchical clustering using R. There is a basic difference between K-means clustering and hierarchical clustering. You should understand and appreciate that. K-means clustering is actually some sort of division cluster, right? You are dividing the whole data into different clusters, and you do not have any hierarchical relationship between these clusters. Whereas hierarchical clustering is agglomerating. You are taking each data point, joining them together to create a cluster. Then you are joining 2 clusters to create a 3rd cluster. So it's agglomerating, right? And as it is agglomerating, you can build a tree architecture showing the hierarchy. You have to understand the difference between these two, because both of them you can use for your same data set, but you have to choose one of them depending upon the utility. You have to understand, is there a meaning of this hierarchical clustering dendrogram, the tree structure that we are getting? If that has no meaning in case of your particular problem, maybe K-means clustering is the best one to do. So you have to understand the difference between what we're learning from these 2 clustering algorithms. Now, using K-means clustering is very, very easy. Essentially, it is a, what we are doing is that you are defining the number of clusters, your steps are iteratively, is the algorithm is trying to create those clusters, and then eventually when it reaches the best clustering, it stops. How do you know that it is a good clustering? Because we can calculate something like within cluster sum of square, right? Between cluster sum of square also you can calculate. In the course, I have discussed about within cluster sum of square, WCSS. So if WCSS within cluster sum of square get reduced, I'm happy. Now remember, in this case, A stands for number of clusters. And as you know from the lecture, we do not know what is the correct number of clusters in the data. If you have some case, you can use that. But in most cases, we do not know. So in that case, I have to use different values of A to the clustering, get the WCSS value for each cluster case, and then I will make a plot which is called elbow plot. So 2 cluster, 3 cluster, 4 cluster, 5 cluster, and you calculate the WCSS for each cases, and you get a plot something like this. And based upon that, you choose a suitable cluster size. For example, in this case, maybe the fourth one is the right. So this is called elbow plot, right? So this is very common. When you are doing clustering using k-means, you have to do that. Either your function do it automatically or you have to do it separately. Then in the next lecture, we will go into hierarchical clustering. Hierarchical clustering will give a dendrogram, T structure. In this case, one important parameter that we have to decide are actually the distances between the measure for the metric for distance between clusters. In the previous lecture, right, in the week 6, the last lecture, we have learned different measures for distance between two data points. But suppose I have clusters of data points. I have two clusters of these data points. How should I measure the distance between two clusters? This question is critical when you are creating hierarchical clustering. That is why in this case, in this lecture, we teach you multiple type of metric for distance between clusters. One of them is single linkage. Then there is complete linkage, average linkage, and central. You should learn how to calculate this, what is the meaning of this, and which are most useful. For example, if I remember correctly, we have given an example where we have shown that actually single linkage is usually not good for data cluster, right? Usually complete linkage or average linkage are usually best. Now, two other clustering algorithms are also discussed, right? Again, we have not got into, we didn't go into detail of the mathematical derivations for these algorithms. Rather, we have visually tried to explain. One is called decision tree classifier, very widely used in clinical sciences. And the other one is the support vector machines, which is now mostly used in almost any machine learning case where you want to create a complicated model. Before that, you use support vector machine to classify the data. So in decision tree classifier, which you should, where you should pay more attention to is that understand how the classifier actually creating the tree. It's a binary tree, right? And then what is the meaning of that tree structure? What is the meaning of each node? And then questions usually comes for Gini index, entropy, information gain. And you can calculate this by manual. Again, in reality, you will not, if you are using an R function to do the decision tree, create a decision tree classifier, you will not calculate yourself this entropy Gini index, right? But you should understand how they are working. To do that, you must learn them to do it by paper and pen. And you will see that it's not so difficult to calculate, right? And we have discussed that actually we have problem of overfitting in case of decision tree classifier, right? And that's to solve this, usually we use bagging. Again, very common question in interviews. People ask, what is bagging? Bagging is right? So it is actually bootstrap, right? You are doing bootstrapping and bagging together. So you are creating a random forest. And what is bagging, what is bootstrapping, that we have discussed in the end of that lecture of that decision tree classifier. So you should be very clear about these two. The last lecture in week 7 is on support vector machines. We start with the idea of maximal margin classifier, though it is not used much nowadays, but this is the beginning. If you can understand what is maximum margin classifier, then you should be able to understand what is SB. If you don't understand that, you will not be able to understand SB. So what you have to understand in this case, you should know what is meant by margin, what do we mean by support vectors, what do we mean by decision boundaries. And once you learn that, the lecture takes you to the support vector classifier, where you use soft margin. The margin is not rigid. You allow some misclassification. and that is the advantage. It avoids overfit. So we are creating SVC, support vector classifier. Then from SVC, we go to SVM. Why do we go to SVM? Because we know support vector classifier work only for linear problem. If I have non-linear problem, I have to go for SVM, where you can have some non-linear kernels. So again, it is a very common question that why do I have to go for SVM? What is the advantage? Why can't I stick to a support vector classifier, right? So this is what all we have in lecture 5, 6, and 7. I have discussed the key point. Lecture 8 will be primarily on dimension reduction for higher dimensional data. You will learn PCA, diffusion maps, and all those things. Again, I believe those are not very difficult. If you have stuck with us up to the 7th week, you will be happily be able to cover the week 8 lectures also. And remember, for week 8 week also, there will be an online session from the PMRF TA. If you have any confusion, please join that and try to get your questions clarified. If there is any question, you can put the questions in the live sessions in the YouTube or here in the Teams. Okay, it seems there is no more questions. There was only one question that was given online, submitted online, whether we can. So Priya has written that, sir, could you please increase my assignment dues? The problem is we have no control over exams. These are automatically decided centrally, and we do not have control, and we should not also control these things because there is a schedule for the whole course. If we keep on changing this thing, that doesn't work out right. Multiple other problems will come. So please stick to the due dates. You have to make a habit to submit within the due date, and it's not so difficult. You go through the course, attend the online session of the PMRF TA, and then eventually that will help you to answer the question in the assignment and submit the assignment in time, right? So we cannot help you in that case. Now, let me come to the end of this live session with a critical discussion on the final exam. So many of you have registered for the final exams for this course. Thank you for that. This will be a computerized exam, just like GATE and JEE. You must have given other exams also in NPTEL, so you are quite habituated, I hope. It will be just the questions will be multiple choice and short answer type, numerical type questions that we are giving you in the assignment. So again, these are not new to you, right? How should you prepare? The most important thing, please don't run around, try to get this video, that book, this book, and confuse yourself. The minimum thing that you require for preparing for the final exams are already given to you. Go through each lecture video carefully. The lecture slides are also available. Please go through those lecture slides, right? Please go through those lecture slides. That is good enough for you. All the codes, all the R codes has been given. These are available on the portal, and also I have a GitHub link which I have given here. This link is available on the discussion forum also, or you search with my name in Git, you'll get the link, you'll get all the R codes and the data used for the live session on R. Go through them. So these three things, lecture video, slide of lecture, and the R codes are sufficient for you to prepare for the final exam. If you want to read other things, if you are an advanced student, that's good enough, fair enough. You can go and study other things. But if you want to do the bare minimum thing, I can guarantee if you just stick to the lecture video, if you go through the lecture slides and the R code very carefully, then you can happily clear the exam with a good grade. But apart from that, you have to do some practice. Practice the problem that has been discussed in the lectures. Practice those R codes. Try to write yourself. Learn which R function is doing what. Go through the assignment questions and their solutions. I repeat again, all the assignments that we are given, even if you have missed some assignment, it does not matter. Even if you have got 10 out of 10 in this assignment, that also does not matter. Please go back each assignment and their solution, learn those problems by heart. I can guarantee that will help you. And also, attend the problem solving sessions. There, our TA is discussing some new problem in every week. She is showing how to solve them. Note down this problem. Solve yourself. If you have missed those, watch the lectures on the YouTube. That link has been given in the portal, right? In the announcement section, and there is a tab where there's a sheet where you can get the link for the YouTube videos of this live session. Watch them. Learn those questions which she has discussed and practice. This practice, if you do, I can guarantee you will get a very good grade in the final exam. Now, one question many people ask that what type of calculator? If you have given NPTEL exam or JEE or GATE, you know you will not be allowed to carry any calculator. But many problems you have to do calculation. So the computer, the software of that will be used for this exam will have a inbuilt calculator that you can use. One example calculator I have given in lane is actually TCS ion calculator. If you cannot remember this link, you can just simply search on the web and you will get it. Please get habituated. Now the last but not the least, one question people keep on asking. Do we need to learn R for the final exam? My answer is absolutely yes. Not just for the final exam. If you want to complete this course and then use it for your day-to-day activity, research and other work, you have to learn R. In exam, we will not give you a task where you write a R script and solve something. No. But there will be questions based on R scripts. For example, we may ask, okay, I have to do linear regression. I am using LM function. What should be the argument inside the LM function? Right? This type of question can be there. Or we can ask, what is the utility of LM function? You look into the question. We have asked this type of question in assignments already. Or we can write a script in R and they can ask you, can you identify the mistake in this? Or I may say, ask that, okay, what is the output of this script? These type of questions will come. So please practice R. As it is essential to become a data analyst, it is essential at the same time to get a good score in the final exam. You have to learn. So there will be R-based questions. So you have to learn. I think that's all for my side. We have almost at the fag end of the session. If anybody of you have any query, please ask me now. Otherwise, we'll end the session. Okay, I think there is no more query, anything here. And we have covered almost everything. So I think Queen or Rekha, whoever is there, should we close it now? Should we close the session now? We can close. Yeah, I I do not see any question anywhere. So let us wait for 2 more minutes. So if any of you are attending this session, please, if you have any query, you can post the query on the team or in the YouTube live session. Okay, I do not see any query anywhere. So let us bring into this live session. This is the 7th week. Next week we'll have the 8th week. So 8-week course will be over. And very soon at the end of this month, there is the final examination. So let me thank you all the learners who has joined this course and registered for the final exam also. So thank you for joining with us. Thank you for staying with this course and learning with us. See you sometime in another NPTEL course. Till then, best of luck. Best of luck for your examination. Thank you for joining.